Okay. Good afternoon, everyone. Thank you for joining IFAS AI and Data Science Seminar Series. Today we have two speakers, Dr. Jaehyun An and Dr. Golmar Golmohammadi. We'll start with Dr. Jaehyun An. He's an assistant professor of artificial intelligence in extension at UF IFAS Agricultural Education and Communication. Previously a research scientist at Texas A&M AgriLife Research, he has leveraged his diverse background in agricultural education, economics, and public health to foster collaboration with organizations such as Howard G. Buffett Foundation and U.S. Agency for International Development and U.S. Department of Agriculture and U.S. Department of Homeland Security and Texas A&M Institute of Data Science. Building on this partnership, he has advanced inventive methodologies and ideas that unite academics, practitioners, and policymakers, driving AI-powered innovation for agricultural and societal impact. Currently, he contributes to AI 771 initiative supported by CGIAR, Bill and Melinda Gates Foundation, UF-IFAS, and the International Fund for Agricultural Development, to develop a large language model tailored to smallholder farmers and extension agents in developing countries. Dr. Jaehyun, floor is yours.
Okay, so let me share my screen. Okay, so do you see my screen?
Yes.
Okay. Thank you so much for a great introduction, Dana. And I acknowledge my mentor, Dr. Laura Warner, and Diana Hagen is working with me for, we just started collaborating with the CGIR for Agri LLM. So I acknowledge Diana Hagen. So I want to talk about today mapping AI adoption in Florida extension, who's ready, who's connected, and what comes next. So these questions are a little bit long, but I actually really tackling social network analysis questions. But more than that, I'm gonna cover a lot, so I'm gonna move fast. So I'm Jaehyun. I'm also like Dana mentioned, I'm an assistant professor, but also I'm a state specialized agent. Okay, so Florida, so we have 67 counties and 360 agents serving their counties. And AI is still new. And then my job is to serve these people, these agents, working with them to show the power of AI. So, but AI has to be, make sure, it has to be making sure that the benefits actually overweighs barriers. So this survey is very new, and this is my first needs assessment in extension. And this survey assessed readiness, perception, and network analysis. So. Okay. So basically, this is my kind of logic map. So I gather samples. So my population is 360 county extension faculty members, and I gathered 140 fully responded responses actually, but actually the full count is of 150 responses. 14 declined to participate. So actually, it actually covers 43 to 39% to 43%. And I use Qualtrics, and then I get an information from February 20th to April 10th this year. So still very new. I have some update. So yes, so I can share some of the results. But actually, there's some research questions guiding this needs assessment. Number one, behavioral component. So what factors shape AI use among extension agents? Number two, social network. Who are the influencers, basically? Who bridges or isolates AI use? Or clustering work is, are there any distinct groups, extension professionals, AI readiness, confidence, or perceptions? And I also gathered not only quantitative, but also qualitative information. So what tools they are using and how they use and how AI can benefit their work, potentially. So I gathered 91 variables. I actually put a bunch of questions. I really appreciate each of the participant, their count extension agent. And yes, so number one is confidence. So whether they are really, really ready to use, how they are confident using AI. Observability is something that I've seen, something like statement that I've seen clear benefits of AI. So 0 to 4 ordinal scale, not at all to extremely. And the AI use is no plan to use it to a regular use. Regular use really means daily use. And influencers, I asked list up to 5 named individuals who are influencing or influenced by AI, and the social ties. Actually, social ties, influencer, AI use, these are really tackling a social network analysis question. And the tools, what kind of tools they are using, and the scenario basis, something that they picture themselves how to use AI. So I use multi-tools to tackle these questions. So number one, I use Excel. So because I actually did a survey using Qualtrics, so I got the Excel file, CSV file, and I actually had a visual check. And this data, I had all the record and then data mining and the multiple imputation to really fill in the missing information. And I exported to R and Python. And the R work, I had a social network map visualization, and also I also had a workout and heat map. The Python is really clustering work. So just wanted to group the people using AI, how confident they are using AI. So, okay. And the really check, so how these 140 extension people, family members in adoption category. So Rogers' adoption or innovation curve. So actually, we don't really have the innovation category, innovator category, but it's a little bit skewed. It looks like a little bit skewed, but it's not. Actually, it's a little bit normal distribution curve. So you can see that the early adopters and the early majority, they are actually willing to use new technologies. So we are actually faster than we think. So we are actually ready to use AI or other technologies. So we are willing. And then reality check number 2 is something that the relationship or causality between confidence and use. So it really shows that you see these figures using Stata, the Stata 18 output. You can see that if they use AI regularly or daily basis, they're really, really confident using AI. So this is something we can imagine, but I actually had a really check. Number 1, number 2, actually had a 10% of missing information. Fill in these information and try again, and you really work. So you can see the gap, but regular users actually have a really good confidence using AI. Okay, observability is key. It's very, very important concept. So Rogers actually provided triability, visibility, or complexity, or compatibility. But actually, observability is really key to use AI. If I asked a question, something that, okay, do you see really clear benefits using AI, others actually using it, and the clear benefits? And yeah, if you see these are yellow line and dots, they are actually extremely confident and extremely willing to use if they see the benefits others using AI. So observability and AI use go together. I actually tested the other questions, the other dimensions or aspects, travelability, complexity, compatibility, but they didn't work. Only observability worked. So observability really key to AI and AI adoption. And then because of this, I actually go deeper social network analysis. So this is a social network map, the first map. So my question really is, who is already using AI and whether or where are they in the influence network? So here, this map, AI network colored by AI user level. So I actually made every single individual participant in ID. So you see a lot of bunch of numbers. These are all IDs. And then you can also see some of the names. They are influencers to these individuals, respondents. And then I made everything, every person, every influencer's pseudonym. So you can't really see the real names, but you see the hub, the center, you can see clear picture that the 51, ID 5124, these are the hub people that actually have a lot of connections, and they are really, really regular users AI. And you can see the people influencers inside, and they're influencing each other. So this is really excellent. This is also very excellent separation between low users and high users. So high users are blue, light blue to deep blue. There's really the kind of distinction. Occasional users to regular users. But gray users, they don't really quite use AI, but they are actually using AI. So I can see clear map who to use, and then what are the influencers, who are the influencers influencing or influenced by. So yep. So it also shows clear network map, the core map and the outside map. So you see on the left-hand side, the STEMIs. This is the real people. This is the real person. Actually, Andrew Ng is another one. They are actually AI gurus, actually influencing AI. So some, actually not many, but some of the extension faculty members, actually they are actually influenced by these people, Andrew and the Demis. Okay, and the other question is how confident are agents and can the confident ones influence the rest? So this is the real question that how confident they are using AI. So it shows the central and peripheral position by confidence really well. So you see the color of the nodes and then slide users and berry users actually located in the center right here. And then 25 and 19, 22, 5. So these people actually shape the center of the map. So these actually influencing or influenced by, and they're really confident using AI. So really showing where confidence resides and where is lacking. And the confidence and the use aligned, but not really identical. So going back to this picture, regular users, occasional users, and non-users, but open to trying. I also had one more category, no, and no reason to adopt any AI. So I have 4 categories. The last category is missing, but I can see clear the picture that who is using AI, who is influencing, and the influenced by, and daily users, and the occasional users. But this one actually confidence and use align, but the not identical. This is something I have to think about. Yep. And here I also have isolate the nodes, and the Demis and the Andrew is also is here too. So so we have to think about. I'll go more deeper on that, but we have to think about that. Okay, so how can we learn from these AI groups and how we can apply these concepts and techniques and technologies, AI techniques, in our extension, so Florida extension. That's a big question for us. And the third map is which UF-IFAS program areas are most embedded in AI influence network. So if I rank them, it's just in order. So the users and then confidence, users and the confidence, and now is a program. So I can really see that, okay, just one of the programs is actually heavily using AI. So it's really well distributed, right? So AI engagement is not limited to just one program. So we have 4-H, we have agriculture natural resources, and we have family and consumer sciences, horticulture, and Sea Grant, right? But you can see the dots, the nodes actually has really, they identified, okay, these are their programs, showing really different different color nodes, and then they are actually well incorporate using AI. So it really reveals a cross-program diffusion, really good potential. So personally, I really like this map. Just it's not really one lopsided, but actually using AI in multiple programs extension. So okay, so social network map summary table really showing that number one, the first social network map colored by AI use level is clear, actionable, shows central adopters. So what is for? This big question for a social network analysis, right? So you can see a lot of nodes, you can see a lot of connections, you can see a lot of colors, but what for? It's a targeting and training strategy. So I already identified the people actually using AI, right? So these are the individual nodes. So I can target them and I can train them. It's like a train the trainer model. So I can do that. So number two, It's colored by AI confidence. It highlights the readiness, bridges to adoption. So it really brings the attention that awareness and supporting planning. So I'm the only individual, and Dana is another individual that we are like a state specialized agents, and we have to serve and we have to work with a lot of extension faculty members. So we have to work with them, right? But we have to see the confidence level, and we have to do this one, and we have to really have a great plan to make an impact. And the third one is program area. So it really clear shows cross-program interest. And then UF-IFAS, we can build kind of organizational storytelling that, okay, we actually have this kind of AI technology. We diffuse this idea. We show the impact. And then our faculty members, county extension faculty members, and we too, we actually build kind of good storytelling, make a good storytelling to AI adoption, diffusion adoption, and the impact. Okay, so this is principal component analysis and cluster map. It really shows three distinct clusters emerged. So number one is that you see on the left, you see the green. You can see also outlier here. So this person or this group don't have any intention to use AI. That's reasonable, right? That's one of the stories right here. And then these are the people, the green dots. These are the people, users that are low confidence using AI. But we have a blue dots right here, no noise between these two. Clear distinction that blue ones, actually they're actually moderate. They actually have really good confident users. And we can also see that the red dots, so these are the moderate users. Moderate users really means that they actually use AI daily basis. So confidence adopters in red is high use, high confidence, and they are central readiness AI users. And the moderate users, mixed scores and transitional behavior. So one of the benefits using this clustering map using Python is something that we can see the clear distinction that low, moderate, and high users. And then because there's no noise, I can really clear target these people, the green ones actually moving toward more like confident adopters, the mid-level, and mid-level, these people to daily users, moderate users. So I can, I mean, this map, I really like a cluster map here. No noise, so I can see how it can move forward. So each cluster can inform targeting training strategies. So basically, one size fits all. It doesn't work at all. And this segment really helps support where we need it and the most promising. Okay, I can see chat, but I can answer later. Okay, so what AI tools they're using? So I recently gathered, before I closed the Qualtrics, I actually gathered 11 more responses, and I updated the word cloud here. And I can see Moline, I can see ChatGPT, I can see Copilot, I can see Gemini, I can see Leonard AI. So these are all like a chatbot. We also have extension bot, right? So actually, we use a lot of the chatbots to multiple things, right? So chatbot is deep learning app. So we use cloud AI too. So we use chatbot for multiple purposes. So ChatGPT, Copilot, and iNaturalist are where they're most mentioned tools. And many actually mentioned that not just one, they use overlap multiple tools. And if you see the some of the tools like a Midjourney or Plant ID or Bing image generator or other various image generators or recognition picture ID. So these are the ones really showing that the image, right? The image picture, and they want to see that what's going on, what the plant diseases are, or what kind of bird it is, or something like that. So for reporting process progress, they want to create some of the images, right? Where Zoom assistant, Zoom actually has an assistant, AI assistant, and it keeps note taking or everything, right? Grammarly for AI generator, kind of making our sentences better. So we use multiple AI ones, but I can tell you is that what I can tell you is that so a lot of tools are embedded in our smartphone. So we want really clear picture that it gives really a direct and a very easy target benefits. So we can have multiple tools. So yes, and think about Economist magazine article. So we asked a bunch of questions. That I mean, this one, the article, Economist magazine article asked what ChatGPT is used. Number one is written communication, right? And the searching for information and documentation, interpreting, some coding. So it really ties in the ones that we are actually using ChatGPT and other Gen AI. So we are in the right angle, I can say. The last result is something about how extension agents using AI in practice. Very similar to Economist magazine. Number one, we can see that the most common use cases in writing, improving text and the content creation. And other things we can think about the idea generation and or program development and the reporting system they want to make better. And yeah, and then respondents vary widely. Some are frequent users, and others, while others are barely mention AI. So we have a gap. Okay, and you can see that x-axis, these are the some of the IDs. So it doesn't really capture all of the participants, but these are actually the most common users on that. So you see the management, writing, improved tools, articles, time, creating. So these are their really plain language that they picture themselves how to use AI, and they whether they can how they get all the benefits using AI. It's like a scenario type question. So what are the next steps? So basically AI use is not random. So its clusters are clear that around confidence, perceptions, and the social position. So yes, and the number two is a small set of central actors may accelerate the diffusion. So the social network map, so three maps really kind of a center for me, where to target, who are the influencers, whether they are in UF IFAS or not. So some of them are actually uh, outside UFIPAS. So who are really influencers? So they are equal influencers who are influenced by influencing. So it really helps me to understand the map, um, the influencers, AI influencers. And adoption is happening, but the confidence gaps and the equity concerns really remain. So the better AI, the bigger the concern and the bigger gaps. So we have to reduce these gaps, right? And develop peer-based AI training models, really leveraging central confident adapters. And I'm gonna use more and more cluster and social network analysis map to show the impact. Okay, so we have the needs based on these assessment. We have this map, but after certain years, like 1 to 2 years, 2 to 3 years, we actually have a better, really tighter map, actually having a really good AI influences each other, right? So we can use more AI for multiple reasons and the multiple AIs, like not only Gen AI, but also predictive AI. And repeat this study in other states or sectors for broader insight. That's my next goal. After I got more study and more taken action for Florida. And the long term is, of course, promote universal AI. So for multiple purposes, extension, we can adopt AI and we can develop our programs using AI. So not only that, I didn't really include, but we also have to think about the data privacy or ethical concerns. So we have to address these things too. So I think this is all I have. So I can answer some of the questions. Dana, can I stop sharing?
Yeah, but maybe audience will have
Oh,
question.
okay.
Yeah.
Okay.
It was very interesting topic. Thank
Okay.
you very much.
Thank you.
Is there any question from audience? Feel free to chime in or put it in the chat. Anyone?
So yes, so I can Yeah, please.
There are questions in the chat.
Yes, that's right, Dr. Mukata. So in the clustering, so I can answer some of the questions. So in the clustering, the first one had the expert sandwiched between the novice and the moderate users, while the expert in the middle. So yeah, that's really good question. So I don't know why I framed this kind of a, so I have to reframe the name. Actually, the moderate users are actually the most frequent users. The middle one is confident. Actually, they have some confidence, but it's not really fully confident. So these are actually, this is moderate. The blues are moderate, and these are the most frequent. So you're right. I mean, but there's no actual overlap. So if you see here green, blue, and reds, it doesn't really overlap that much. So I can see really clear distinction. So and Dr. Mukata also asked, interesting word map, ChatGPT is not recommended. That's right. So so this question is actually tricky. So yes, so ChatGPT is not allowed. So this question actually is what kind of experience they had. So ChatGPT could be, right? So what kind of experiences they had with AI. So actually I throw that out, the questions. So they answer freely. So I wanted to have their honest opinion. Yes, you're right, Dr. Mukuta. ChatGPT is not allowed, but I actually wanted to have really kind of their honest opinion. And
There's one question in the chat also.
Yeah.
So clusters were similar in size.
Closer,
this-
similar in size. Yeah, that's another good point. Yes, if you count the dots, they're similar size, right? So really, why do we do PCA, principal component analysis? So we want to make really complex or complicated dimensional maps into really low dimension. So this one looks really simple, kind of a clustering map, but actually I had a lot of different predictors to cluster this. So looks simple, but inside is very complicated. But yes, scale is very similar scale. So each of them, and
we will have one more question from Franta.
Yeah, thank you. Great presentation. I really enjoyed it. And I think you just answered my question, because I was going to ask, what is your principal component 1 and principal component 2? And it looks like each component is actually a cluster of different factors that would influence the sorting. So I think I got it. And then I have a quick question on when you showed your network maps, it seemed to be heavily centered. Is it the typical case for the social networks, this heavy centering, or should there be more interconnectedness at the peripheries? What would be preferred, and how could we achieve that?
Yeah, what a great question. So this is exactly right. So here we can see really small circle. That's a small hub. The center is really small. So my goal is that, okay, I'm going to work with the people right here, the ID numbered IDs. So these are the individuals, county extension faculty members, our family members. And I want to build this small map, the small circle to bigger circle. So it's like this. So that's what I wanted to do. So another one is a tighter ties. If you see the distance between the nodes, I mean, these are really long distance, right? So I want to make it tighter, the social ties in using AI. So that's another work I have to do. So yes, so this is the needs assessment results. So some are expected, some are not expected. So yes, so that's my work. So yep.
Okay, thank you.
Thank you.
Thank you. It was a great talk.
Thank
We'll
you. I'm
go-
gonna stop sharing.
Yeah.
Okay.
Thank you.
Thanks.
Now we're going to the next speaker of the seminar, Dr. Golmar Golmohammadi. Are you ready, Golmar? Golmar, are you there?
Hello, yes.
Yes, yes. Okay, thank you.
Yes,
So,
so
okay.
I share my screen now, right?
Yes, please. Yeah. I will introduce you to the audience. Dr. Golmar Golmohammadi is an assistant professor leading the Hydrology and Water Quality Lab at RCRC since 2022. Her integrated research and extension program focuses on application of hydrologic modeling and developing sustainable water resources. by adopting appropriate water management method and implementing the best management practices to sustain water resources and production while protecting water quality. Golmar, the floor is yours.
Sure. Do you see my screen?
Yes.
Okay. So hello, everyone. My name is Golmohammadi. Thanks, Dana, for introducing me. So my today's talk is about application of modeling and AI in the area of water resources. And I focus on the work that we are doing here in Florida. So, okay. So since establishing my program here at University of Florida at Range Cattle Research and Education Center, so I have one of the central goal has been to support water resources management and the long-term actually health of the grazing land system here in Florida. To achieve this goal, we have like laid out like very clear roadmap for ourselves, and our my research here at Range Cattle has three foundational phases. The phase one, establishing a robust monitoring and instrumentation network. Phase two, it's about like existing condition evaluation of the situation of grazing land. And phase three is about implementation, translating our research findings into practical and practical implementation strategies. So, so here we started our research by building a foundation, installing monitoring stations to gather key hydrological and water quality data. So what we have done, we with collecting data from available sources. And I mean like different organization, for example, like USGS or like the water management district and so on. By looking at the wells and hydrodynamic stations, you will see here in this map, the red symbols are the surface water stations, flow stations, and the green dots are green groundwater wells. So by looking at them, we will see that despite the general idea of that we have like, these are basic data and they are available everywhere. But we see that that's not actually true. And we can see by looking at a spatial distribution of the wells and the stations, there is a lack of information in many areas. And to date, our here at Range Cattle Research Education Center, we have installed more than 35 monitoring stations across the world. The instrumentation network connected in two research sites. We selected two research sites of Range Cattle, which is located at Ona, and the Luca Preserve, which is a University of Florida research property. These sites were selected because of the accessibility to the field and the resources actually and permits for instrumentation. And these instrumentation allow us to actually enable us to collect wide range of data, which is essential for our research. So the goals there was about like this, whatever I talked to you right now so far was about the first phase, which was instrumentation. This is an ongoing phase. But by the way, while expanding this network of instrumentation in Florida, we also launched the second phase, which is evaluating the current condition of our watersheds, study areas here in Florida. So the main goal was to provide a tool to be able to simulate the groundwater and surface water systems, evaluating the effectiveness of existing and alternate BMPs in improving the water quality and quantity in Florida's cattle ranches and underlying superficial aquifer. So for that purpose, developing numerical model or like hydrologic model was one goal, and the other one was AI modeling techniques to be used to forecast or simulate groundwater and surface water parameters. So the models could be very useful and efficient tools, and it has been, if it has been used properly. So in our research, we use various modeling techniques to simulate and to predict important hydrologic and water quality parameters. And we have also used modeling techniques for long-term evaluation of conservation practices. As you see, like here in this flow chart, I'm showing the modeling work that we are using, like for numerical model development. This is the work that about developing different physically based or hydrologic based models, numerical models or physically based model, to be able to simulate the long-term conservation practices and assessing their impacts on environment. So we have used both physically based and numerical based models like SWOT, SWIM, ModFlow, or any other type of models that we have used. These models are very, basically, they are very, they need a lot of investment in terms of time and technical knowledge. So a key focus of our program then became harnessing AI, power of AI in our research to be able to reach the goal of modeling and hydrology and water quality and the impact of those on environment. So our AI research here at Range Cattle Research and Education, it focuses on three main areas. Like one was the AI as forecasting tool to simulate and predict water quality, hydrology, and environmental conditions. So the second one was to use AI as a risk assessment and vulnerability analysis tool. And we are talking about geospatial maps of Florida to be developed for risk assessment and vulnerability analysis. And also the third one is like the focus number 3 is about AI as a service, which is an ongoing research, a tool for landowners that they could use the AI platform for decision support system, as a decision support system for delivering insights directly to stores of lands, managers, ranchers, and farmers. So the effort of our team in the area of using AI as a forecasting tool has been published in different journals, and like we have used this actually this work for different parameters related to soil temperature, to soil moisture, surface water discharges, groundwater elevations, and water quality in surface water system in Peace River Basin of Florida. So we have published 4 papers from it, and we have more publications like under review for this. This is only about like AI as forecasting tool. So, but between these areas that I have talked about here in this presentation, I'm going to show you the application of AI as a forecasting tool for surface water discharge in river systems and groundwater elevations in superficial aquifer in the state of Florida. So we have used various numerical models in Florida. As I mentioned before, in 3 sites that you can see here in this map, the Luca Preserve and Range Cattle Research and Education Center and Buck Island Ranch, those are the areas that we finished modeling studies there. So for that purpose, we went through a comprehensive background review and data collection, and we have done a lot of analysis. So we have developed conceptual models for the modeling purpose, which gave us a solid understanding of fundamental hydrogeological concepts and mechanistics principles here in these areas of Florida. So we faced some challenges, such as like while we applying these models during the modeling process. One of them was about lack of data, especially when we looking for long-term data. That was one challenge. And these models are also expensive, time-consuming, and those are expensive in terms of users as well. So a strong knowledge of science and engineering behind the model is needed, and they are not easy to use. So considering these calibration of these models, sometimes it's like almost impossible in some areas. We change so many challenges to calibrate these models, especially when we are thinking about the water system complexity in Florida. The idea of using AI has formed then. So we thought that AI possibly could help us in terms of different issues that we face. Using AI could help us to, get over the lack of data, because in AI models, sometimes it's often unnecessary to explicitly include all parameters involved in physical process. So that might be helpful in places that we don't have enough data, or like funding for data to be used for numerical models. AI could help. Timing, like AI models significantly accelerate the modeling process in many cases. So that could help in timing as well. So AI models are particularly well suited for larger scale applications. So that's another thing. And since we are looking at larger scale, we are looking at the whole state of Florida as our study area for most of the works. So AI could help us. We thought that AI could help us in that too. So this study conducted a larger scale analysis across the entire state of Florida. In this research, we systematically evaluating the efficiency of a machine learning model to simulate groundwater level and surface water flow. To do that, first we looked at the background of AI in water resources. So, and we just had a good knowledge about that. And then we selected 4 different machine learning models for this forecasting purpose. The models that we selected are long short-term memory, LSTM, neural basis expansion analysis for interpretable time series, and which is called NBITS, neural hierarchical interpolation for time series, which is NHITS, and transformer. So we chose these models, like, for example, LSTM networks, because it's very good at capturing long-term dependencies in time series, which is critical for hydrological system influenced by past precipitation and seasonal effect. They are widely used for stream flow forecasting before, and groundwater elevation forecasting, including in ungauged basins. So that's why we selected LSTM. The NBITS is a deep learning, deep neural architecture model for univariate time series forecasting. Doesn't rely on domain-specific assumptions. So, and it usually outperforms traditional statistical and deep learning models. And there are lots of use of this model in many cases in hydrology, but not water quality. So that's why we picked this one. And it's like building on like NBITS, and NHITS uses hierarchical interpolation and aggregation to enhance long horizon forecasting. And because part of this work, we wanted to forecast the groundwater level and surface water discharge, so we choose this model. Transformer has been used less than any other machine learning models before in hydrology, and it used attention mechanisms to capture long-range dependencies in time series without relying on recurrent structures. So originally developed for natural language processing, So they are like adopted for time series, and we are working with time series. That's why we chose this model as well. So by having those 4 models, so we can see in this picture and in the table how our model being able to perform and forecast the groundwater level and surface water discharge. So a spatial distribution of best performing deep learning models for predicting surface water discharge and groundwater are presented, and each symbol presents the model that achieved the highest predictive accuracy at given station. For surface flow stations, which is the green symbols, you can see that for that one, you can see that NBITS is the best model. In most areas, most stations, NBITS appears most effective model in various parts of the state of Florida. Particularly in the central and northern region, you can see NBITS are, we are having more NBITS actually over, like perform better than the other models. And for like, in case of groundwater wells, groundwater level elevations, the model of NBITS, like that was the best model. NHITS model are widely effective across the state, and it was the best model for groundwater. So our analysis revealed that NHITS model consistently deliver superior performance for groundwater, and for surface water, it was NBITS model, which was the best model. And you can see the graphical, actually the plots of the comparison between the observed and simulated simulation of these 2 modeling results for both groundwater and surface water. But in general, most of the machine learning model, they did perform well in simulating both parameters, and it shows that the machine learning application for simulation of groundwater level and surface water discharge in the river system and aquifer of Florida are actually good tools. So then the next step was like forecasting. We extended our analysis by applying the top performing models, which was NHITS for groundwater and NBITS for surface water. You will see these graphs, like the left one was the best model for groundwater, and the one in the right is the best model for surface water. We are showing how they work for future. So based on the availability of 20 years of data, we had like our model was actually the simulation period was from 22 to 2023, 21 to 2023, but then we extended that for forecasting. We performed forecasting for the next 21 months from June 1st, 23 to 25. To March 25. The forecasting results are presented visually here with a blue line. As you look at the blue line is like the forecasting at the end of the graph. So we chose this 21 months because we had the data for still available from the organizations for this period, and we wanted to see how our model gonna perform for future forecasting. So so this was the work about forecasting, like using AI as forecasting tool. Now I'm gonna switch to the next part of the work, like research focus, which was about like risk assessment or susceptibility assessment tool, just to use AI for that purpose. So for this work, we have used like AI as this. For this purpose, we have used AI for different susceptibility and risk assessment studies. We have done flood susceptibility. we have like almost about to complete groundwater vulnerability. We are looking at AI as a tool to do the drought and sinkhole, and all of them are for the state of Florida. Most of the work here in this stages, they are ongoing, and I would share the results hopefully in near future with you. Here in this presentation, I decided to present the flood susceptibility word as something presenting our AI application as a tool for risk assessment and susceptibility. So let's look at Florida, and Florida is being, we know that Florida is being historically susceptible to flood due to its unique geographical and weather conditions. And this issue usually causes devastating financial losses and large displacement of people. And so this is like about flood in Florida that we all know about it. Flood susceptibility map in general initially have been developed to identify and characterize potential flood-prone areas. Could improving mitigation measures, it could be used to, according to specific conditions of the state. So those are like importance of flood susceptibility mapping in Florida and the purpose of it. So the flood susceptibility methods are like were traditionally conducted using various conventional methods such as hydrological, hydrodynamic, statistical, and multi-criteria decision analysis. Those are some examples, are methods which have been used traditionally to develop the flood susceptibility analysis or mapping. But design of the flood susceptibility maps has been enhanced through the hybrid machine learning and deep learning methods. Although these methods have achieved most of the time better results and better accuracy compared to traditional models, but they were not being widely used by stakeholders due to the black box nature of them. In this study, we applied an explainable artificial intelligence, which is called XAI model, that incorporates the Shapley additive explanation model to interpret the outcomes of our AI models that we have used and analyze the impact of variables on flood susceptibility mapping. So what we have used, the primary goal of this study was to develop an accurate and interpretable flood susceptibility map for the state of Florida, and some specific objectives, what to choose different models, which we chose CNN and ResNet to predict flood-prone areas. And second specific goal was to incorporate Shapley additive explanation to interpret the CNN or ResNet model predictions. And the goal number 3 was to identify and analyze the key factor influencing the flood susceptibility in Florida. So although the number of methods is quite high, I named some of those in previous slides, but the number of parameters that we usually use for this type of studies varies. It's not like certain number that we use those parameters for sure. It depends on us and how data availability in our study area is, so we can decide how many input parameters or impacting factors to be used. Here in this study, we used 13 flood triggering factors encompassing geological, soil, and forest attributes in Florida. So we use land use, topography, and land use itself. Like we have used different parameters of it, different portion of land use, like forest and wetland and drainage. Those are the things that we separated from land use because we thought that those have like individually it's important or interesting to see the impact of those. Topography and slope, lithology, and soil attributes, of course, like those are the ones that we selected for this study. So then we started the data processing in GIS, and this is, I'm talking about the traditional method very quickly. I don't spend time on it because this is one method called analytical hierarchy process, traditionally being used to develop or to generate flood susceptibility mapping for decades. We used this method just because we wanted to compare our AI work with this one. So this is the map that we have created using AHP method. So this method is generally working based on weighting factors. And this is the map of the flood in Florida. It starts, like you can see, 5 different categories of high risk to open water in this map. So the next step, which I'm gonna talk about here, is data processing. So it's about flood susceptibility mapping using our AI models. Again, we used 13, my apologies, this should be 13, this is a typo, 13 flood triggering factors encompassing the geographical and soil and forest and land use and everything that we had in our traditional method. Again, we used here. The only difference is here we needed one inventory map to be able to train our data based on that. So this flood inventory map is what we have used for this purpose, and we got this map from Florida Department of Environment. So data processing, pre-processing was the next step. So we collect the data and 13 geospatial input parameters like soil, slope, and everything I named before. And one flood inventory map was used for this purpose, all in GeoTIFF format for consistency in spatial analysis. And then we made sure that uniform spatial resolution of all of them are kept, like, and coordinate reference system and file format across all data sets are the same. Spatial alignment and cropping was the next step. We cropped all the raster or all the TIFF files to fixed spatial boundary to ensure consistent pixel count and alignment. Handling missing data was the next step, and then what we did was normalization, applied normalization to rescale pixel values between 0 and 1, because some of them are like had values, different values. And then we did raster tiling for scalable processing. We divided everything, and we had the tiling split each raster layer into 128 to 128 tile, and we generated, which in total we have 316,000, more than that, like tiles per parameter. And then multi-band raster stacking was the next step. We had to, at that step, we just stacked all the 13 different input tiles into corresponding flood inventory tiles, and resulted in one stacking product with 14 band raster tiles, like 13 features and one label, or that is the flood inventory. And then we use the binary thing to label the flooding area, either flooded or non-flooded pixels. And we use 70% of the data for training and 30% for testing. So, and at this point, we have done all the training and testing and data pre-processing, training and testing, and we just moved to the models that we have used. We have selected CNN models, both of them. One is 2D CNN convolutional network, neural network, which is like we are using a specialized deep learning model called 2D CNN. And CNN architecture was comprised of 4 feature capturing convolutional layer and final dense fully final dense and fully connected layer to learn about feature classification. And this is one common model that we use for this type of risk assessment and image processing work. The other model we have used was ResNet, or residual network, which is a deep learning architecture designed to solve the problem to training very deep in a very deep neural network. And in traditional neural network methods, as a layer added, the model started performing worse due to issue like vanishing gradient. But here we just in ResNet solve this by introducing the concept of residual connections. So we call it escape connections. Instead of trying to learn the full transformation from input to output, each layer or block in ResNet only learns the difference. So in this project, we use ResNet 50 model due to its robust and well-proven architecture. So here you will see the flood susceptibility map is created. So here I'm just showing one of them, which was the better results, like FSM-XAI is the ResNet one, which was better than CNN traditional one. So by comparing and we have compared the flood inventory map, which we have it from Florida Department of Environment, and the traditional one, which is in the middle, and the AI one, and we will see AI has like performed way better than the other two. So what we did at this point, we used the SHAP system, or detailed explanation of SHAP, which is like a method based on game theory to explain individual prediction of any machine learning model. This is something makes our models not like which actually has a black box nature to be able to interpret them. And like the SHAP calculates the marginal contribution of any feature that we enter as input by comparing outcomes without or with those features in. So this is the way that SHAP model works. So I just go to the next slide, which is the results of our SHAP. So there are usually when we do SHAP or explainable AI technique, we get two types of outputs of explanation. So here, one of them is the summary plot, and the other one is the individual plot. The summary plot is for the whole study area, while the individual only explained to us what was the most important thing in one pixel. So here I'm just showing the summary plot for whole Florida, and if we look at the summary plot, we actually determined the drainage was the most important variable influencing flood susceptibility here in Florida. This is comparison between all the inputs that we entered, like land use or like forest and everything. So, and this is actually something can be interpreted as so many, Florida is heavily dished, and for a long time from 1960s, actually like ditching thing or drainage in Florida started, and that can have a large impact in flood susceptibility areas in Florida.
Golmar, can you wrap it up soon?
Yes. Pardon?
Oh, so we're over the time, so can you wrap it up soon?
Sure. This is my last slide, Dana. I'm sorry. I'm just going to finish in 1 minute. So our finding about Florida susceptibility map just was generated by AI, was like we had a higher accuracy compared to traditional methods. And using this XAI SHAP approach, we could identify the importance and influence of the parameters. And the approach can be used for other actually susceptibility assessments, such as groundwater vulnerability, drought, and sinkholes. And the next step of this work is we are going to turn this this research into something practical and easy to use. That's where we are, and we are already commenced this research, like the last part, which is the interactive AI platform. We are building an interactive AI platform for stakeholders, landowners, and producers. No technical, which very little technical background is enough to use that platform. So this platform will let the user to view AI generated maps that like we have generated here at ONA, or like everything that we get from data and all the services for water, soil, and climate, and get tailored recommendations for their specific land and region, and plan around like real-time and long-term evaluation conditions. So thank you very much for your attention. And yeah, I would be happy to answer any question.
Yep. We'll take one question from audience. Is there any question? I don't see any question. Oh, yeah. Oh, no. Okay. Golmar was a very informative presentation. I'm actually very interested in XAI, so I will contact you personally
Sure.
for your research question. Thank you again for the speakers and also audience to participating in the AI data science seminar series. This was the last seminar in the spring semester. We'll meet you again in the fall semester. Thank you.
Thank you.
Thank you. Bye.